Yeah. Yeah. Hi. Good morning, all of you guys. Hope all of you can hear me. Yeah. Just give me a second. Yeah. Hi, guys. Good morning, all of you. Hope all of you can hear me. Can anyone, guys, can you please confirm is I'm audible?
Yes, sir.
Right. Right. Thank you, guys. So, guys, in the last session, I have been started with some introduction part of data science and like what is machine learning. Just to give an idea about the, we have not started with any technical aspects actually, guys, but it is going to be something like I just started with some kind of an a small introduction part. I have been got started with that. Right. I can see some guys has been joined for the today's class. Anyone, can you please, who has been joined for the today's class? Can you please let me know, guys? I think Kajal, you joined Revati. Yes, Savita, are you my old student, Savita?
Yes,
Okay,
Vamsi.
last 1 year back.
Yeah, I couldn't complete it, so I
Okay,
thought
okay,
I'll be joining.
okay, fine. Okay, right. Yashwant, I think joined. Yep. Please let me know, guys, so that I can just discuss like what I think I can see some few people. Ashish, I think today is your first class, right?
Yes, sir.
Is it right?
Yes.
Yeah. Okay. Even that. Okay, fine. Just no worries, guys. Who has been joined for the today's class? Just let me explain about that. Just a two introduction classes, guys. Saturday, we didn't had the class. Only Thursday and Friday, only just a hardly 2 hours of session. You can also get the recording, and the two, it is nothing has been happened because we are still in the introduction part only, guys. Okay. So we started with something about like what is full stack data science course? What is our course first of all? Like what topics, what concepts we are going to learn in our classes? Just an idea, just an introduction part only. We are there actually. Okay, fine. So we started with something like what is full stack data science course, like end to end, whatever that is required to work in a data science project. So we have to require all that particular skills actually. Why? Because data science itself is an what is learning a data science. So it is not like you are learning Java, you are learning Python, or you're not learning some language like which is going to be some. It's not like a learning of a language. So we are learning a data science. Data science is all about learning some various techniques we are going to be learning actually, guys. Techniques means there are different types of methodologies we are going to learn and different types of algorithms we have to use, a different type of systems we have to use, and a little bit different types of processing techniques we are going to be using. Finally, we are using all these kind of a techniques and methodologies. Mainly our target is only one thing. We have to understand the data. So why we have to understand the data? So if you have understood what has been happened in the past, if we can analyze what has been happened in the past, based on that, we can do some kind of a prediction. So what could happen in the future, we can identify, we can predict it actually, guys. That's why data science is all about some kind of an predictive analytics actually, a predictive analysis, what we have to do it actually, guys. So like, as I said that some examples I told you about that, like in a business perspective, like banking, sales, etc. If you analyze the past sales data, you can predict like in future how much sales we can reach or how the sales are going to be there, whether they're in uptrend or downtrend, or something like in a banking applications. Like if you analyze your past customers data, so to whom I have to give the loans, to whom I should not give the loans, or let's say past whatever the marketing data we have been got done. So in future, who could go for the investments, who would does not goes for the investment. So we can do some kind of an predictions actually. So like even in the clinical data in healthcare, so diagnosis some kind of in specific diseases or something like that, we can predict it. Or in research data, so like we can do some kind of in satellites, IoT devices, etc. If we analyze this particular data, So like when the earthquake is going to be gets occurs or something, the satellites, which is going to be the earthquake, cyclones, etc., we can do some kind of a predictions also. And I told you about the 80% of our data science course is going to be gets contains something called as a machine learning. So machine learning means don't worry about that, sir. What is deep learning or all these things? Because deep learning is a part of machine learning. I have not yet started with any practical. If anybody has joined for the today's class, don't worry about that. If you have any doubts, I'll clarify it. So 80% of our data science course contains, which is going to be machine learning. Mainly machine learning is important. After that, you go to deep learning because deep learning is also part of machine learning only, guys. So that's why I'm not specifically saying that even the deep learning is also going to be a part of your machine learning only. So that's why I'm just saying that 80% of the time we are going to work with machine learning and deep learning applications only. We are going to be gets working with that. So understand, give the past data to the machine, give the past data to the machine. Machines are going to understand the data actually, guys. So as we discussed, so we are not going to understand the data. So machine learning is one of the technique I'm going to be using, guys. Machine learning is going to be one of the technique. It is one of the technique which we are going to use this. We are making the machines to learn that from the data actually. Machines will learn. We are not going to learn anything from the data, but we are going to make the machines to understand the data. We are helping the machines to learn from that particular data. As I said that, in our school days, how we have been went to the school and how the teachers has been helped us to learn. Same as it is, we are also going to be help the machines to learn it actually. That is what the machine learning is going to be all about that. Okay, so skip them, does not matters with that. I just given some idea like which is going to be how a normal traditional programming language is different from machine learning models. In a normal traditional programming, I just explained the application, guys. If this is our input actually, guys, X and Y is going to be our input and Z is going to be our output actually. X and Y is our input, Z is going to be our output actually, guys. So what is going to be, that means if I want to derive this Z from this X and Y, if X is 10 and Y is 20, your Z value will be 30. If X is 100, Y is 200, your Z value will be 300. If X is plus 1 and Y is minus 1, I want to get 0. If X is 5 and Y is 6, output is going to be 11. So this is our requirement. It's a very small requirement I have been given. If I give it to a normal programmer like a C, C++ or a Java programmer, he will understand the logic behind them. Okay, this Z is coming from addition of two numbers. So he will write a logic as a program and he will give the program to the machine along with the input. Your computer runs the program according to the input and according to the logic and gives the required output, whatever you say. If I give 5 and 70 as an input, you will get 120 as a result as an output. And I have written the logic inside that. But in a machine learning applications, it's not like that actually, guys. We simply give the input as well as output. So what is the input? What is the output? I'll give it to the machine. Now machine is going to be, machine means here the computer. The computer is going to understand how this output is derived from the input. Based on that, the machine is going to write the program for us. So I don't say that machine writes a program, but machine is going to understand the data and how that is derived, it is going to tell you. Got the point? So machine learning is nothing but where you give the input as well as give the required output also. Machine is going to understand how that output is coming from the input. And based on that, the machine is going to write the logic for us. So machine is writing the logic for us actually, guys. That is what exactly the machine learning is all about that. But to perform that, what are the technical aspects I have discussed? So it's not practically, guys, but once I can recollect once. So we have been seen. First, we have to collect your data. First of all, your past data, you have to collect it actually, collect the data. Sometimes your old data may be there in some legacy systems, in old type of systems, it will be there. So collect all your required data actually, guys. So here we are going to learn a different skills. We are going to learn it actually. Reading the data from CSV, text files, Excel sheet, JSON files, XML files, or some kind of a database systems like Oracle, SQL Server, DB2, MySQL, or any such kind of a cloud storages like Azure, AWS, or Google Cloud Platform, GCP. So data maybe nowadays can be available in any types of location. It can be there. It's not like it will be available only in one type of location. Nowadays, hundreds of different storages we have got. After collecting the data, who is going to do the data collection? User. So as a user, we should know. As a machine learning expert, we have to know how to collect the data. It is a technique actually, guys. It is a technique actually, guys. So don't think that data is going to be available in always in a free format and application. We have to know about that. So data may be available in different styles. A data going to be available in a different formats. The data is going to be gets existing actually. That is what we are going to call it as a data collection. For that, I'll show you one. That means you are not aware about all these things, but just I'll tell you, like reading the data, collecting the data is not that much an easy technique actually, guys. It is not going to be that kind of an easy technique. It is going to be. I'll just show you one small example. Why I have got the thought is in the today's morning only we have been started working with the data set. So everybody has been taught that it is very easy and simple application only. So don't worry about that. So don't worry about the code I'm writing it actually, guys. Have a look at this application actually. Normally, if you look at the data looks to be very simple and very easy. Okay. But I'll show you like what are the different problems you are going to be getting it actually, guys. Don't worry about what is the code I'm writing. If you are familiar with that, no worries. If you are not familiar with that, don't worry about that. Okay. So actually, this is one data set actually, guys. One CSV file was there. It's a simple CSV file only, guys. Okay. So we are trying to read the data. In the morning only, we have been started working on this data. So we got an issue actually. So let us say that this is going to be actually what is the data actually here is, guys. The data of the terrorist attacks on different countries from almost all from somewhere around 1970. From 1972 up to some 2020 or 2021. So what are the different attacks or different the terror attacks that has been happened? So we will hear about the news only that has been happened in India or something like that, isn't it? But in real application, that means in our daily life, there are so many different countries are there. So see that everything appears to be very easy. If you open the file also, it looks to be very easy actually, guys. But there is one small issue with that actually. I was also unable to trace out where is the problem is there. We tried to trace out, but we didn't find out where is that particular problem is there. Some kind of a character which is not satisfying our Unicode characters. That means A to Z or something like 1 to 10, 1 to 0 to 9, they can be easily understandable. But some characters are unable to understand. So somewhere in the file, there is one small character which we are unable to recognize also actually, guys. It looks like to be our normal. It looks like to be a normal character, but that is not our Unicode character actually. So that's why if you want to read that data, see, this is what I'm going to be talking about that. So normally everybody can read the data, but unless and until he do not know any idea about the data set. So somewhere the mistake was there. Somewhere a small mistake was there. It's not a mistake, some kind of an character that has been came, or it may be something like which is not a Unicode character. See, so that data has been came now. Clearly the data has been came. 1,56,772 rows with 14 columns of data, what we can see it actually. Just an example I'm showing you. Like this is going to be the data actually, guys. Let me show you like which is going to be in India, how many we have it actually. Just don't worry. Don't worry about that particular code, what I'm going to be writing. Just it is going to be just an idea about that. It is going to be, what is the name of the column? It is country. Do you have it? Okay, no worries. No worries about that. We'll try this country under C. In real applications, your data is not going to be that much easy like it is going to be looks like actually, guys. It is not that much easy to looks like actually, guys. So this is going to be the terrorist attacks that has been happened from 1971 to which is up to here. We are having up to 2015. We have the data actually. So what are the particular cities, locations? Okay, in South Asia, it was there. In India, these many we have it actually, guys. 9,940 rows of data that has been taken actually. 9,940 terror. It's a kind of a terrorist attacks. So we heard about the news only about the major attacks only. But every day at the borders, they will be having a lot of attacks will be taking place actually. So we do not know about those particular date actually. Can you see? This is going to be 1997 in Maharashtra, Bombay. There was there actually. Location summary was not there. Some of them are we going to be. We can see some lot of summaries what we can see it actually. So they threw a grenade at and so and so location. We can see that in Jammu and Kashmir in 2015. So we don't know about that, but some of the data we have been heard about that. Major attacks only we know about that. But small attacks every day, there will be a lot of attacks will be going on. So 9,940 attacks that has been going on. So the idea here is every time normally it looks like the data, unless and until you go deep into the data only, we cannot identify. Normally, if I open the file and see that, normally I can open the file actually, guys. Normally I can open the file with a normal notepad and you can see the data actually. Okay, everything data looks to be very simple data only, but somewhere there was a mistake was there, some problem was there. So identifying that particular problem, how to handle that, that is going to be important one actually, guys. So that is also one of the very important skill actually. Don't think that every time data is going to be in a structured format, in a pure data format, and pure clean data will not be there. That's why we have to know about the technique. So what is this encoding equals to ANSI? So why I'm using that? So we have to understand at the time of implementations actually. So collecting the data is one of the skill. Data analysis. So we have to analyze the data also. Whether the data is in a proper format or not, we have to analyze the data. If it is required, we have to, sometimes if any dirty data comes, it may be a dirty data or what we are going to call it as an untidy data comes. So we have to clean the data actually, guys. Sometimes if it is required, we have to visualize the data. So we have to do some kind of a visualizations, like just an example, no worries, which is going to be terror underscore, which is going to be df dot, which is going to be, don't worry about that. Just an example I'm writing, which is going to be, let us say, country underscore text dot, which is going to be value counts. So like example, I'm just writing it actually. Don't worry, I'm just writing. So I just want to know about what are the top 10. I want to know that actually. So top 10, that means the highest which has been done dot, which is going to be plot dot, which is going to be something like the bar chart actually. So what is an importance of the data visualization? So data visualization also plays an important role. Why? Because is unless and until you don't visualize the data, we cannot understand that particular data. We cannot do it actually. What happened? Just a second. Right. So this is going to be, just see that it is going to be telling in terms of, instead of looking at the values, we can see in Iraq, we have the highest number of terror attacks. After that, Pakistan, India is at the third place, Afghanistan, Colombia, Peru, Philippines. Okay, so something we can see that United Kingdom, Turkey, we can see that application actually. So it's an advantage of a data visualization skill actually. So data visualization also plays an important role. So by using some kind of an Python libraries, we are going to do that, matplotlib, cbound, or any Python libraries we'll use. And as well as I told you, we are also going to be working with a GUI-based tool, like which is going to be a Power BI tool. Also, we'll work with them. Then main important is training actually, guys. So machine is learning means, first of all, the machine has to be given some training. We only train it actually. Train means we don't say that this is what you have to learn, this is how we have to learn it actually. Machines are capable to learn by themselves. Training means nothing but we are giving some training to the machine. Once we have to tell that, like an example, I can tell you in an easy way actually, guys. I'll tell you in an easy way. For example, what do you mean to say training actually? Now let us say that, guys, we have some images, the images of human faces. It is going to be some kind of an human faces are there actually, guys. Our target is very simple. Our task is a very simple task actually, guys. Whenever I have given the human face, the machine has to tell me whether the image, whether the person in the image or the human in the image is a female or a male actually. So this is what my machine has to tell me. The machine has to tell me whether that image, the person in the image is a female or a male actually. That is our requirement actually, guys. You can't write a Java program for this. No doubt at all, guys. We can't write a Java program for this. So human face image is an input actually, guys. It is not just like a input as a number or a string. It's an image. Image is an, here the input is an image to the program. And the output of the program should be, it should be tells whether it is a female or a male. So how can you write the code for that? If you give me a number, I can say I can compare whether it is less than 1000, greater than 1000. If you ask me, I can write a logic for that. Whether it is a prime number or whether it is a non-prime number, I can write the code for that. But from how can you write a code for the images, which is going to be image is an input here now. So for that, what I'm going to do is, first of all, I have to give some machine keys capable to predict it. But before that, what we have to do is, guys, first of all, we have to give some kind of a set of images. I have to give it actually. First of all, I'll give some images to the machine actually, guys. And I will say the machine, I need not to write any code. I'll say that the person in the image is a female. The person in the image is going to be a male. The person in the image is going to be again a male. And the person in the image is going to be nothing but it's a female. Okay. You have to give the images, this a set of images. And we also has to tell what is the label. Label means nothing but what information we have it actually. If I give it to the machine, now the machines will study. The machines understands how the females are differentiated or they can be separated from the males actually. We only give the image. I'll tell you how to give the image to the machine. Okay, we don't directly give the image to the machine. I'll tell you, you know that image is made up of some kind of a pixels. Image is made up of a pixels actually, guys. Pixel is nothing but a color representation. Later we'll work with them. First of all, we have to give some training to the machine actually. Training means nothing but where the machine will learn. So this is the images, and these are the whatever the gender of that particular person in the images actually. So machines are going to be trained. Machines are going to be trained, and it will understand the data. It will differentiate. It will learn from the data. Okay, I can differentiate between the males and the females. Now, once the machine has been learned, whenever I give a new image, whenever I give a new image to the machine is going to tell you whether it is a male or a female. It predicts. It predicts saying that the person in the image is going to be a male. The person in the image is going to be a female. But for that, what we have to do? First of all, some training is required. First of all, some training is going to be required actually, guys. Machines are trained. Machines are going to learn. We are going to give some training to the machine actually. But how do you write? How do you give that particular training? We don't give write any functional code for that. So if this pixel value is less than this, if pixel value is greater than this, the machine does not study. We don't write any code. Machines will learn. Machines are going to learn from the data actually, guys. Okay, so for that only, we have to require something what we are going to call it as the training is going to be gets required actually. But it's not with 3 or 4 images. Like for example, if I give a training to a small kid, so give some, take a 3 years or a 4 years child who can 3 to 4 years means, okay, he was well differentiates between the colors, etc. So give some training to them, give a training to the child. You are giving a training, showing some kind of a red color fruit. If I show a red color fruit and say that this is an apple. So you know that children are going to be, the kids are going to learn everything with the colors the colors only. That's why during the childhood, during the kids of 3 to 4 years, they are going to everything. We don't know that, but teachers knows about that. The kids are going to be given the training with the help of the colors only, colors and shapes. The human brain cannot study all the things at a time. So slowly it has been developed, isn't it? So first, the human brains are going to be distinguished between the colors only. They don't study the alphabets. They don't study the numbers. First, colors and shapes. They don't know what are the colors, but the human brain is going to learn. So, okay, this color is going to be blue. This color is going to be green. This color, they don't know about the shapes, square, rectangles, they don't know. But they can distinguish between them actually. If I give a square color and ask you to place in a square location, they will identify that actually. So give some training. Red color is an apple, and which is going to be an yellow color is going to be, let us say, a mango. For example, show an yellow color mango and a red color apple. So whenever a child looks at a red color fruit, he will always say it is an apple only. Whenever he sees an yellow color fruit, then he will say that it is a mango. For example, if a child never seen a banana, we didn't given any training on banana, but whenever I show a banana with an yellow color banana, if I show, the child is going to say that it is a mango. Why? Because the child human brain was trained only with the red and the yellow colors only. So first we have been given some training. So saying that this is red, this is an apple, this is an yellow, this is a mango. When I explain like that, his brain also will train like that only. And whenever I show some any yellow color fruit, if I show them, they says that it is a mango. If I show some other red color fruit, if I show them, they say that it is going to be an apple only. They can't differentiate between the shapes initially. The same way, the machines also has to be given some training. So these are your images. These are going to be this particular images, and these are going to be the people inside the images. But only with 3 to 4 images, machines can't learn it perfectly. Humans can learn with 2 to 3 examples, but machines are going to require a lot of data. Maybe somewhere around 20,000 images we have to give it actually. Give 20,000 images to the machine, give 20,000 images to the machine and ask it to learn. You just ask it to learn, machine will learn it. Okay, after that, you give any new image, you give any image, the machine is going to be capable to tell whether the person in the machine is going to be male or a female. So the one of the question that raises here is, sir, how can I have 20,000 images? How can I have a 50,000 images? I want to have it actually. How can I collect it actually? You don't worry about that. Why? Because we have a lot of the data sets are available. They are available, guys. They're available for us. Even it is available with me also. With me means I didn't collected the data manually, guys. I didn't collected the data manually. I'll show you some data sets which we can see the data sets actually, guys. Just a minute. It is going to be project, right? See the images actually, guys. These are the images of 24,000 images we have it actually, guys. At different ages, at the different genders. Different genders means only 2 genders, males and females. But how I collected all these images actually, guys? I didn't done anything. If I really want to collect 25,000 images from the internet, and if I want to mark them as males and females, marking them is what we call it as annotation. Data annotation is what we call it as. So even nowadays, data annotation tools also has been came actually, guys. That means, for example, unless and until I say that the person in the image is a female to the machine can't study that. So manually, you have to make an entry saying that this is a female, this is a male. Instead of doing that, there are some data annotation tools are already there. If you give the image, the data annotation tool will directly tell you whether there are males and females. It is going to tell you actually. 24,000 images at a different ages with males and females, we have the data set actually. This data set was contributed by one research community actually, guys. Even we have Indian celebrities images, actors, players, sports persons, celebrities. So many people are there actually, guys. So this is not collected manually by me, and you also no need to collect it actually, guys. So even the old age, like 112 years, 110 years, up to 116 years of age people are there. Starting from 0 years. Starting from 0 years or 1 year, up to 116 years people, the ages data is there. How I collected this data actually, guys? This is just a simple download actually, guys. So that is going to be an UTK data set, what we are going to call it as. So don't worry, this is going to be the data set actually, guys. From here only, I downloaded this data set. It's a simple download. So somebody has been contributed 1.3 GB of the data was there. Just if you download, it will just click on that. It will download your data set actually. So machines require, the only thing is machines are also just like humans, but only thing is machines require more and more data actually, guys. 20,000, 30,000, 50,000, 60,000 images they are required. Then only the machines are capable to learn. Otherwise, the machines are not capable to learn it actually, guys. So what I'm saying here is some kind of a training is required. Training means what has been happened. What has been happened. If you just tell it, The machines are capable to learn by themselves actually. Machines will learn, but I told you how the machines will learn. Machines are not going to capable to learn automatically by themselves, but there are going to be with the help of some kind of an algorithms they will learn it actually. There are different types of algorithms will be there. We have to choose that algorithms, and based on that algorithms only the machines will learn it actually, guys. Okay, so the training the machine learning model here there where the machine is going to learn with the help of that algorithm, and how effectively the machine learning has been learned and how to improve the performance is main important part. And after that, finally, it is going to be deployment of the models, what we have to do it actually, guys. So deployment into a local system, or mainly we are going to be studying about how to deploy it into the cloud and how to access them. That is what we are going to be gets working with them. So these are the things, guys, which we have been got learned in the past session. We have been in the last 2 sessions we have been got discussed. So training is nothing but just tell them this is the data, this is the label. So these are apples, these are oranges, these are females, these are males. If you tell them, the machine can start studying from that particular data actually. Okay, so that is what I'm going to be calling it as a training concept actually. So anybody who has been missed the last 2 classes, couple of classes, this is what I have been got discussed in the last session we have been got discussed. It's not the main concept, guys. It is just a concept of just an introduction part we have been got discussed about that. Okay, so here the main question here is what are these algorithms actually? So algorithm is going to be nothing but, guys, it is going to be a kind of a solution to a particular problem. So depending on the data we use, depending on the problem we are using, it is going to be, we chooses a different algorithms. So here what we are going to learn, we are going to learn about the algorithms. So which algorithm solves what kind of a problem? Because when you go to the real time, every business will have their own problems. A telecom company is there that will have some kind of an, it is having its own problems. A banking applications are there. So it is going to be having its own problems. So depending on the data, depending on the problem you're solving, we are going to choose as which is going to be the right algorithm. We have to choose it actually. So for that only, we are going to be giving some training here now. Like which algorithm works in what way. Okay, when do you choose which kind of an algorithms? What are the strengths and what are the weakness of that particular algorithms? That means when it will works perfectly, when it does not works perfectly. Every algorithm works actually, guys. Every algorithm says that we are going to learn, but the main problem here is in some situations, some algorithms are best, and some situation, the same algorithm may be worst. It's going to be learning worstly. It is going to be learning actually. So algorithms are going to help. The algorithms are going to help the machine to study from that particular data. So algorithm defines how to solve a problem. It is a mathematical or a statistical solutions. So if you want to study, I told you, go for something called as what are ML algorithms actually, guys? What are going to be ML algorithms? So I told you, instead of asking Google, so nowadays we are asking, we have changed our, we have been changed, guys. So we have been moved to ChatGPT, isn't it? So we have been moved to the ChatGPT. So ChatGPT directly tells you no need of checking the links and all these things not required. Just a second. We are asking it. So what are machine learning algorithms actually, guys? So we are asking what are going to be the machine learning? What are machine learning algorithms actually, guys? So whenever we said what are going to be, so ChatGPT, guys, start using them. So as I told you, this is going to be what are machine learning algorithms. So machine learning algorithms are nothing but the mathematical models that enables the machine to learn from the data without being explicitly programmed. It is a mathematical model, a mathematical solution to say that. A simple mathematical solution. So guys, every problem in our real life can be correlated to a mathematical application or a mathematical representation. Generally, we don't know that, but every step or every operation you perform or any activity you perform in our real life is going to be can be represented in a mathematical model. So machine learning algorithms are the mathematical models that enables the machine to learn from the data without being explicitly programmed. As I said that they use some statistical technique to learn some patterns, relations in the data. They will study how this is correlated, what is the pattern we are finding, and then make the predictions or decisions based on that particular pattern. It will study the patterns, it will study the correlations. So based on that, it can do some kind of an predictions what we are going to do that. Remaining are technical aspects, so I don't want to work on them, guys. I don't want to work on them actually. Okay, so these are going to be some of the algorithms actually, guys, like linear regressions, decision trees, k nearest neighbors, support vector machines, SVM. Even I told you, guys, deep learning neural networks, and many more are there. And I told you the choice of algorithm depends on the specific problem being solved and the characteristics of the data. So as part of our learning, as part of our training program, what we are going to learn actually, guys, we are going to learn the things like what is an algorithm, how the algorithm will works, okay, what is the maths and what is the statistics behind them, because every algorithm is a mathematical model. There are going to be some kind of statistical techniques they will use as actually a mathematical model, but internally uses some statistical techniques it is going to be uses actually. How to control the algorithm and when it is going to be best suitable for which type of problems we have to use and which type of problems we should not use it actually. That is what we are going to learn as part of our course curriculum actually. Okay. So just a small technical aspect I'll add it for today, guys, just for add a small technical aspect for today. Okay. So as I said that, for example, in this case, actually, guys, your input is going to be images. Our inputs are going to be images. Your output should be nothing but the gender. Your target is nothing but the gender. You want to predict the gender. So that means that your machine learning model has to predict what is the gender of the person in the image actually. So sometimes you may give the images or you may give some other features also, like what is the age of the person, what is the height, what is going to be the BMI, and what is going to be the weight, something. I'm going to be giving some different types of information. If I give the values like that, the machines will study. Or if I give the image, the machines will study actually. Anything machines can study. Not only with the images, guys, even if I give the voice, that means the human voice. If I give the human voice is nothing but an audio, isn't it? If I give the voice of multiple people to the machine can differentiate between those particular, what are the particular, the voice between the difference between a male and a female actually. So genders we can identify even with the help of their particular voice also we can identify. The machines can differentiate between males and females also. Same technique is required, but here in the place of images, we have to require some audio files. We have to require some audio files. Along with the audio file, we have to tell whether this audio file belongs to a female, whether this the audio file belongs to male, or whether it is a female. Once if we give it to the machine studies the data. And in the place of image, if I give a new voice, if I give the new audio file, the machine is going to predict with a male and a female actually. Why? Because even the voice, by using the voice, we can differentiate it. So when somebody calls you over the phone, even if you don't look at the person also, you can differentiate between whether the person on the other side is a male or a female actually. We'll do all these examples, guys. I'm not going to be telling only these are the possible cases, and images we work with them, guys. Audios we are going to work. Text data we are going to work. Normally, we work with all types of data. We are going to work with that. Audio examples also there. Again, we have to require some kind of an audio file for our training purpose. How do you collect the audio files? You don't require it actually, guys. So for that, as I told you, there are so many research organizations are there actually, guys. They are contributing all these kind of a data actually. This is one more data set we are going to use this. Can you see? The data set contains 8,732 labeled sound data actually, guys. Labeled means what is the audio file and to which class, to which label it belongs to. But here it is not male and female. There are different types of audios are there, like air conditioner audio, the sound of air conditioner, car horn is there, children's playing, dog barking, drilling machines, engine idling, gunshots, jackhammer, siren, and which is going to be street music. So 8,732 data files are there, which will be around the size of this data set will be around 6 GB of data set actually, guys. 6 GB of data set it is there. You can download this data set also actually, guys, free of cost. These are all public data sets. Anybody can download these particular data sets. These are public data sets. Anybody can download this. Some research people has contributed this data actually, guys. See, this is a free research organization actually. They are doing some research on the audio files. So you can download that particular audio files. You have to just a small Google form will be there. Just there is a download form will be there. So we can just go to that particular download form and just fill up the details. You can just download it actually. Or there is some pip download is also there. Right now you don't know. Python download is there. You can directly download a package called as a sound data. And then from there also we can get that particular data set also. So multiple ways. We have multiple ways. Either direct download is there or directly there's a Python package is also there. Later we'll work on that actually. Not only from that actually, guys, even by using some kind of the text that has been got written. So there are going to be some text articles. So somebody has written an article, whether that article was written by a female or a male, we can differentiate it. Why? Because how can you differentiate the male and female by their voice? Or how can you differentiate the male and female by their particular facial representation? Even from the text also we can write it without looking at the face of the person, without hearing about the voice of the person. Only by using their vocabulary we can identify that. Why? Because researchers have found that the vocabulary used by females and males are quite different. So what kind of words females will use? What kind of words the males are going to be used? Completely there is some differentiation is going to be there actually. But that is a little bit not that much accurate, but voice and audios can be well differentiated between males and females. Whereas in text data, we cannot differentiate it, but 80% they can be differentiated. Remaining 20% may not be differentiated, but voice and audio, more than 95% we can differentiate it. But 5 to 10% you cannot differentiate it because some of the male voices will be heard like a female. Some of the female voices are going to be heard like a male. Even some of the facial also, some of the males looks like a males, some of the males look like a females, some of the females will look like a female males actually. So something like that, we cannot differentiate it, maybe 5 to 10%, but remaining we can well differentiate it actually. Okay. So today a small technical aspect, just 2 terminologies I'll add it, don't worry. Later in our actual classes, we'll again have a discussion about that. As I said that your machine learning model or a deep learning model, don't worry about that. Machine learning model or deep learning model. I told you no. A machine learning model is nothing but model is nothing but an object actually, guys, which will be trained or which will be learned with the help of an algorithm. What is an algorithm? An algorithm is nothing but a mathematical model. A mathematical model by using which the machine will learn it actually, isn't it? Okay, so whether it is an ML or a deep learning model, it is doing some kind of a prediction. Observe carefully, guys. If prediction is going to be like a male or a female, okay, or in a medical diagnosis, like whether it is a positive or whether it is a negative, okay, or anything actually, guys, it can be male, female, or positive, negative, or whether it is going to be a defaulter or a non-defaulter in a banking, defaulter or a non-defaulters. Okay, so this type of data is what we are going to call it as a categorical data, guys. Don't worry. Later, again, I'm going to be discussing about that. So remember, normally this data, what type of data it is? Normally, if I ask a normal people, they says that it is a text data. But in our machine learning and data science, we don't use text data, guys. We are going to call it as a categorical data. The term is very quite relevant to that, categories. So these people are belonging to 2 different types of categories, males and females. These patients are going to can be categorized into 2 categories or 2 classes, which is going to be positive or negative. And these customers can be categorized into two types, which is defaulter, non-defaulters. Don't think that there are always only two categories, guys. It can be 3, 4, it can be anything. So this type of data is what we are going to call it as a categorical data. Whenever your machine learning models are predicting the categorical data, this type of tasks are what we are going to call it as an, I told you know, that type of the algorithm we are going to be choosing is going to be depending on the task. Depending on the task, what we are trying to, what is the task we are going to be doing it actually. As I told you, the choice of algorithm depends on the specific problem or a specific task. We call it as a classification task or a classification problem. So whenever you want to develop a machine learning model, which can predict which is predicting a categorical value, that type of algorithms or that type of a problems are what we are going to call it as a classification task. For example, if you are trying to predict something like what is the next year stock price, how much stock price we are going to be, how much stock price, or which is going to be what is going to be house prices actually, or it can be anything actually, guys, like what is going to be the charges that has to be paid by a particular company, or if I do this much investment, how much returns we have to get it. So these are going to be some kind of values, some kind of a numerical values actually, guys. These are what we are going to call it as a continuous data. So only two types actually, guys. A machine learning model or a deep learning model, which is predicting a categorical value or which is predicting a continuous value. If it is predicting a categorical value, we call it as a classification problem or a classification task. Whenever we are predicting a continuous value, this is what we are going to call it as a regression task or a regression problem, what we are going to call it as. Terms are new terms to you guys. Once again, when you go to the actual machine learning discussion, again, I'll elaborate it more and more about that. Okay, so two terminologies I have been added actually, guys. One is categorical and continuous. What is a categorical data? Whenever your data is going to be just like only distinct values like that, we can also call it as discrete values also. You generally know what they mean to be a discrete value actually, guys. When you are having a very few number of different values are there, they are called as a discrete values. They are called as categorical data. Whereas whenever the data is going to be continuous, continuous means a numerical value, which is not like a distinct value. So I don't say that the values are going to be salaries of, you can talk so many guys, salaries of the employees, or maybe height of a students or weight of a students. We don't say that salaries of employees should be always something like 5 lakhs and 6 lakhs and 7 lakhs. We don't have only these type of distinct values. 5.25, 5.6, 5.8, 5.85. You will have a different values are there. Those are what we call it as continuous data. So if you are trying to predict a categorical value, that task or a problem is called as a classification task. Whenever you are trying to predict a continuous value, that task or a problem is called as an regression task or a regression problem. I told you what are the different algorithms are there. Depending on the problem we are solving, the algorithms changes actually. So just an idea, regression examples actually, guys. There are simple linear regressions are there, or we are having something called as an logistic regression. These are the algorithms actually, guys. What I'm talking about them, they are the algorithms. So to solve a regression problem, we use regression algorithms. What are those? Linear regression, logistic regression, we have a ridge regression, we are having a polynomial regression. So many are there actually, guys. It's a polynomial regression. So many are going to be there. Coming to the classification task, we are having a different types. Most popular, I'm writing it actually, guys. Like we have a decision tree. We are having a KNN, which stands for K nearest neighbors. We are having something called as an Navi base. We are having something called as an SVM. We are having something called as a random forest. Simply writing as an RF. RF stands for random forest algorithms. So these are the different algorithms to solve a different problems. Then you get a doubt. Why classification we have decision tree, KNN, Navi base? I told you no. It is depending on the problem you are solving, as well as it is also depends on the whatever the type of the data we have it actually, guys. So what is the data we have? and what is a problem we want to solve it actually. These two factors will decide this particular algorithms actually. So if you see that, you can see some kind of an examples actually, guys. Like you can see, I told you know, some examples of machine learning algorithms includes linear regression, decision tree, k nearest neighbors, support vector machines, SVM, deep learning neural networks, and many more is going to be there. So I ask, what is the difference between classification and what is the difference between a continuous data and a categorical data? So what is going to be categorical versus which is going to be nothing but we can call it as continuous data. So it has been error has been occurred, some error has been got occurred. It is going to be something like, okay, categorical versus continuous, or let us ask it. Just can ask it actually, some error is coming actually, guys. No worries, no worries. Let us ask it about difference between, we'll say that, or we can ask, what is the difference between, we know that no guys, chat GPT, every day you are hearing a lot of news, it is ask you are hearing about a lot of news. It's still in the testing version, no? So it will take some time. Difference between what is categorical versus which is going to be the continuous data. Let us ask it one more time. So error is occurred. Okay, fine. Leave it, guys. Instead of generating it multiple times, wasting the time, we can go for. Okay. Otherwise, we'll ask what is going to be classification versus. It is a classification versus, which is going to be nothing but it's a regression actually. So what is classification versus regression? So there is some problem is there. So it's some problem is not from our side. So maybe some huge hits are going on. So that is the reason why it is taking some lot of time. It may be taking some time. No worries. We'll ask the Google search. What is categorical? What is categorical versus which is going to be the continuous variables? So I told you, categorical variables are nothing but some kind of a discrete values. You can say that categorical values also called as discrete variables. This comes only in a fixed number of values like dead or alive, obese or overweight, normal, underweight. Okay, something like that. What is going to be continuous values? They can be value between a theoretical minimum and maximum values. Like what is going to be the birth weight? What is the BMI? Temperature? What is going to be the neutrophil count? They are not like a limited number of values. They are not like a fixed number of values. They are what we are going to call it as a continuous data. So whenever we are trying to develop a machine learning model, which is trying to predict a categorical value, they are called as classification. Whenever we are trying to develop a machine learning model, which is predicting a continuous value, is what we are going to call it as a regression variable, guys, a regression task or a regression problem or whatever we call it as. Okay. So these are some kind of a terminologies what I'm going to be using them actually. So categorical versus which is going to be continuous, and the other one is going to be nothing but what we can say that a classification versus regression. So don't worry, the terminologies may be new to you, but don't worry about them. So in our later classes, we are going to be looking into that, into more and more detail. We look into those particular applications, guys. Okay. So that's it actually, guys. That's it. The examples, what we can talk about them. I don't want to go into deep into that particular topics actually. Just an outline I have been got given. Like some terminologies, machine learning. So machine learning is going to be nothing but I told you the definition also. So according to Arthur Samuel, what is machine learning? Machine learning is nothing but where we are giving the ability to the machine to learn by themselves without using any explicit coding. Without writing any explicit coding, machines are going to be capable to learn. We are giving the ability to learn from that particular data actually. If the machine learning model is if the machine is trying to learn from the data to predict a continuous variable, we call it as a regression task. If it is trying to predict a categorical variable, that is what we are going to call it as a classification task. Examples of classification algorithms. You have to use an algorithm only, guys. We've seen that what is an algorithm actually, a machine learning algorithm. A machine learning algorithm is nothing but a mathematical representation, or it is a mathematical model to make the machine to learn it actually without having any explicit coding. So these algorithms can be classified into different types: supervised, unsupervised, reinforcement learning. I'm not talking about that. But there are going to be classification algorithms, decision tree, KNN, Navi Bayes. All these are going to be comes under the classification task or classification algorithms. What are regression algorithms actually, guys? Like a linear regression, logistic regression, ridge regression. So many are there actually, guys. Okay, a ridge regression, all polynomial regressions we have. We have so many other things are also what we have it actually. So many different types of regression algorithms are there. So in our course curriculum, what is our main concept here is, guys, we are going to learn about these algorithms only. So which algorithm, how it will works. Data science is all about learning about algorithms only. So if you see the definition of data science also actually, guys, you ask what is data science? You ask what is data science actually, guys. So according to the definition of a data science, what we can see it actually, guys. Observe carefully. What is the definition of a data science? A data science is an interdisciplinary academic field that uses statistics, scientific computing, scientific methods, process, algorithms, and systems to extract or extrapolate that knowledge and insight from the noisy, structured, or unstructured data actually. It is not learning about a tool or not learning about a language actually, guys. It is an interdisciplinary academic field that uses statistics, scientific computing. So some kind of scientific computing systems they'll use this. There are some different type of scientific methods we'll use. Processes we are going to use. Algorithms we are going to use as actually, guys, and systems. Mainly our target is only to one thing, extract some knowledge and insights from that particular data. Data is not a clean data. Sometimes it may be noisy data, or it may be sometimes structured. Sometimes it may be unstructured data also. That is about this particular, what we can call it as a data science. So there is a Wikipedia page is also there. You can just understand it actually. So it is going to be some kind of you can say that actually, guys, it's a unified concepts actually. Data science is a concept of unified statistics, data analysis, informatics, and their related methods. Mathematics, statistics, computer science, information science, domain knowledge, all these are going to be gets required actually, guys. So initially how it was started, okay, early days 1962, John Tukey, he is one of the father of data analysis actually, guys. He has given me so much theories to this particular modern data science, what we are using now actually. So the modern usage, how it was done, all these things we can see it actually. Okay, so just it's a small reference pages. If you want, you can study with them and we can see the data actually, guys. Okay, so we are not working much on that. So just it is the ideas like what is data science, what is machine learning. To get some idea, we have been got discussed about this actually, guys. Okay, so that's it from my side, guys. That is going to be from my side. And with this, I'm going to be ending up my my introduction classes and demo classes. Don't worry. These are all only introduction classes, guys. Maybe most of you will understand only yesterday's. Still, the main dilemma most of you people are having here is, up to now, you came to know that you are studying that programming language is required to make the machines to understand the understand your application actually. But now I'm saying that you don't require to write any particular program. Directly, machines are capable to write the program by themselves only. They will write it. So leave it to the machine. So machines are saying that from so many years you are writing the code saying that the Z is equal to A plus B. So why do you write like that? You don't write like that. You give directly the X and Y. I will identify how that Y is derived from the X, and I will tell you directly how this particular Y is going to be gets coming to you. Okay, but further you have to tell me the input data and what is your output data and what is an algorithm I have to use for learning procedure. So machines can't decide the algorithms. Machines has to be given with some algorithms. Use this algorithm to learn. Use this particular algorithm you have to use for learning. So like that, we have to give some inputs to the machines actually. Then the machines will study with the data actually, guys. Okay. So with this, I'm stopping with my demo classes also, guys. So from tomorrow onwards, we'll be starting with the regular classes. So generally we'll give 3 days demos actually, guys. So you have to register for the next day. That means for the regular classes, if you have joined for today, there is no problem. But from the last couple of classes who has been joined, so please register. My backend team will contact you If you have any further discussions, you can discuss with them related to the fees, payments, and all these things. So initially, the fees payment is going to be for 16K, guys. I think already they have been shared that particular the message in the chat window. Okay, they have given all the details, guys. So you have a number is there, contact number is there. If you have any concerns, so you can talk to my backend team. They have already given the bank details and all these things they have been given, guys. So if you have any further discussions, you can just contact them for their particular people. And I'll also give my number also, guys. So if you have any concerns, you can just contact me actually, guys. Okay. So just a minute, I'm giving my number also, guys. So if you have any questions or anything, if you have any concerns, you can feel free to discuss with me, guys. Okay. So it's my 8080777117 is my contact number. You can just message me or you can call me, guys. Please message me. If I was not in the calls, I can respond you. If I was not in the classes, I can respond you. Otherwise, I may not respond. So please message me if you have any concerns. Okay. So that's it, guys. That's it from my side for these 3 demo classes. If you have any questions, I can just spend some time for you guys. Yes.
So can you repeat your number?
Yeah, 8080777117. Yeah, I'll just a minute. Don't worry. I'll share it here in the chat window. You can have a copy. You can just note it down. Right. This is my number, guys. I've shared with everyone in the chat window. You can just copy it. If you have any concerns, guys, just please reach me out if you have any problem. Right.
Yeah, I'm having one. I'm having
yes.
questions after
Yes.
this meeting. Can I call you in person?
Yeah, you can contact. Yeah, you can contact.
Yeah, just before this meeting ends, no, and then only I will call you.
Yeah, just after. Yeah, sure, guys.
Okay.
Thank you. Yeah. Any guys, any questions? The guys who has been joined for today, if you have any questions, you can feel free to discuss with me. You can unmute yourself and you can speak.
How many days will be having this demo class, sir?
Demo class is for 3 days, basically. Have you joined for today? Is it your today's the first class? You can attend another 2 more classes. I think demos are going to be like, and demos is nothing but, see, demos are not like, just it is going to be my, like we are just explaining like what is our course curriculum, how it is going to be there. So if you are satisfied with this, you can restart yourself for your course. If you still have any, you're in a dilemma whether to go for this course or not. So you can attend another 1 or 2 demo classes and then you can restart for the course. Right. Yes, Ashwant, do you have any question?
Vamsi, I have a question.
Yeah, Ashwant. Yeah,
Is it possible to change the timing half an hour before it's 8:30 to 10?
Because 1 hour is going to be too less, Ashwant, basically.
No, 8:30 to 10. I'm asking.
8:30 means it becomes, because I have to check with the other guys
because,
also.
right, most of the people are working people.
We thought the same thing. Okay, but I cannot immediately change it. I'll take the response. I will take the input from you guys also, because see, if there are another 3 or 4 guys are there who cannot attend. See, so most of the people, it is half an hour. It is not a problem. But for one person, I cannot change it. I cannot disturb the other one also. But I have to check with my team also. Why? Because the link, for example, whatever it is already used by some other session up to 9 o'clock. So I have to just give me another 2 more days of time. If it is possible, I will just update you.
Sorry to disturb you guys. Even I was also thinking if the session is started 7:30 a.m., maybe it will be helpful because
No. 7:30 we already have a class, Kajal. 7:30 we already have an old batch. So we cannot do that actually. So in the case, if you are familiar with any Python to say that, then if you want, you can join that particular, because already Pandas was already started. It's almost all 1 month, 1.5 months. So hardly possibly is going to be 8:45. Why? Because almost all 7:30 to 8:30, I already have a class. Generally, the class will extend a little bit, 5-10 minutes. I'll extend it. 8:40 or something, it will be extended. But please give me another 2 more days of time, Ashwant. I can update you once. If it is really possible, I don't have any problem to shift the batch. If at least I can change it to 15 minutes instead of taking 1.5 hours, 8:45 to 10 o'clock, I'll take it actually. At least whatever the possibility is there, I can just try to check for the maximum possibility. Okay, fine. Yeah. So by 10 o'clock, we have to end up, right, Ashwant?
Yes, yes.
Okay.
Because
I'll
at 10 o'clock
I'll try
already
to
it's
at least I'll try to make it at least for 1 hour 15 minutes or something like that. I'll try to make it. I'll confirm it once again. Right.
Sure.
Right. Yes. Right, guys. Hope all of you have got some idea about that. So from tomorrow onwards, I'll start with the introduction to Python classes, guys. From tomorrow onwards, we'll start with the regular session. So just before starting with that, just a 15 minutes, a small discussions are there. We'll complete off that in the tomorrow's class. And then I'll start with the introduction part, guys. Introduction to Python, I'll start with them. Okay. So thank you all of you guys. And I'll see you tomorrow at the same time, same link at the same 9 o'clock, guys. Thank you for today. Have a nice day.